Okay, hey guys, happy snow day. Hopefully you'll see these notes. They'll be helpful in terms of reviewing and in terms of learning. Make sure that you watch the whole video, get all the way through so that you can come in and be ready to ask questions. This is the last thing that's going to be on our quarter 2 test. So please make sure you study this well and make sure that you're practicing the exit ticket and the quiz. This is going to go on quiz 11. Okay, so what we're doing is we're still starting our polynomials. This is going to be just like solving quadratic equations, where we have to do something with factoring, and then we're setting each factor equal to 0. But since we're in polynomials, we could have degrees that are higher. See how this is a 3? The degree, highest exponent, the degree could be greater than 2. So we have to factor in a specific way. The most important thing, however, is this part right here. I've seen a lot of mistakes on quizzes. I've seen a lot of mistakes on tests before. We need this polynomial to be equal to 0. Currently, it is not. So I need to move all of the terms to the same side. So I will do that by subtracting 3x. Okay, since there is no other x terms over here, this is an x cubed, this is an x squared, we can't combine any like terms. So this makes it 2x cubed minus 5x squared minus 3x equals 0. And so now we are ready to start factoring. And now that we see this equal to 0, we're ready to go. Okay, the first thing we should always look for when factoring is to pull out the GCF. Okay. Now in this case, we're looking for both powers of x and numbers. I don't see that these have any numbers in common. There are no factors that each one would be divisible by, but everybody has at least one x. So I'm going to pull out that one x. When I pull out that one x, think about dividing each term by that great GCF. So here, if I divide out 1x, I'm left with 2x squared. Then here, I'm left with minus 5x, and then minus 3. Still equal to 0. Okay, so that GCF will actually become one of our factors that we're going to write down. But first, let's factor the rest of this. Okay, and you can choose to factor whatever way you like. I'm going to factor by our little tree method. So remember, for those of you guys who need a reminder, at the top of our tree goes the first term, so 2x squared. At the next one goes our last, so negative 3. And then at the bottom, as our check, goes the middle term. So it spells out almost film. First, last, middle. You can think about film being the kind of acronym to remember. So the only two factors of 2x squared are going to be 2x and x. And now the only two factors of negative 3 are going to be either 3 and negative 1 or negative 3 and positive 1. It might take you a couple tries to put it in the right place, but I am going to try negative 3 and 1 to get there. All right, and then I multiply down, so I've got negative 6x plus 1 times x, so plus 1x. Does that equal negative 5x? Correct, it does. So my factors are 2x plus 1 and x minus 3. So I'm going to write that over here to the side. I have factored, and I have 2x plus 1, okay, and then x minus 3, still equal to 0. And those are our factors. So I'm going to write that in my blank down here. My factor is x, 2x plus 1, and x minus 3. I like to keep the parentheses so I know what goes with what. Okay? But in order to find the zeros, and if I was in class, this is where I would ask you all to tell me the other 3 words that zeros mean. Zeros are the same as x-intercepts, roots, and solutions. And we call them solutions because they are the numbers that make this equation true. They are the numbers that would make this equation equal to 0. Okay, so I'm looking for the x-intercepts. The way that I do that is I take each factor and I set it equal to 0. completely independently of all the other ones. We're trying all the possibilities. It could be that this factor was equal to 0. It could be that this factor was equal to 0, or it could be this one. Okay? So our first one, we don't have to do any math. X equals 0. That is one of our roots. Here, we need to first isolate the 2x by subtracting 1, and then divide by 2. So we get x equals 1/2. That is another one, another 0. Here, I'm trying to get x by itself, so I'm adding 3. So I get x equals 3. Okay, those are my 3 zeros. Okay, here is how to put them. We can take these and put them on the graph, and that will help us kind of sketch our equation. So I've got x equals 0. Okay, I've got x equals 1/2. We'll call that something like there. And I've got x equals -3. We'll try to scale that a little better. Okay, now you're thinking to yourself, how do I know which way my graph should go? I know that it should go through these things, but I don't know if it should start from up here or down here. Well, remember, we can go back and look at our original equation in standard form. Okay, I'm looking at the term with the highest degree. That's the term that matters. Highest degree means highest exponent. So I see that this term is both positive, okay, so positive, and the degree right there is odd. Okay, if it's positive and odd, that means that it must start at the bottom and end up at the top. Odd means opposite end behaviors, and positive would be like a positive slope. So we need to start at the bottom and go through each of the x. Oops, I missed that one. Let's try that again. Okay, each of the x-intercepts one time. And that's important. I go through them one time because each of them has a power of 1. Okay, and so that is a rough sketch of my graph. Remember, you can always check by using your calculator. Okay, all right, I'll do another example. This one will go a little faster though, just so I can, excuse me, get this out of the way. Just so I can get to everything else in this video. All right, so if you have questions on this one, make sure you come in. You could also pause the video here and try this one yourself, see if you get it right. Okay, so remember, the first thing I need to do is set equal to 0. That means I need to move this term to the other side. Okay, so I've got 3x to the 4th plus 5x cubed minus 50x squared. And notice that I put it in standard form. That makes it easier to factor. Okay, I noticed that my GCF, well, it could have been 5, but this one's only got a 3. So 5 is, there's no number that will have these in common, but everybody has at least 2 x's. So I'm going to pull out not just one x, but an x squared. You can think of that as pulling out x times x. Okay, so if I take out 2 x's, that leaves me with 3x squared plus 5x minus 50. Okay, good. And then I can factor. Okay, I am just going to factor in my head. If you need to write down the tree, that's totally okay. All right, so I know I've got 3x and x. Okay, some factors of 50 might be 10 and 5. So one has to be positive. So let's make this one positive 5 and negative 10. Remember, to check if this is right, I need to FOIL back out. So I would get 3x squared minus 10x minus 50 and then plus 15x. I did a loop. You can FOIL though, but this is correct, okay? So my factors are x squared, 3x minus 10, and x plus 5, okay? I take each of those and I set it equal to 0 to get my zeros, okay? Okay, and I'm getting x equals 0, x equals 10 thirds, and x equals negative 5. Now there's something really special about this one, okay? The first thing I notice is that the degree of this polynomial is 4. That means that there should be 4 x-intercepts. Right now, I can only see 3 of them. Well, how do I know one is not imaginary? And it's because of this power right here. If I see a squared outside, so if it was here, or maybe if it was here or here, if I see a squared outside any of my factors, that means it counts as 2 x-intercepts. We call that a multiplicity. Of 2. That also means when we graph it, that the x-intercept will bounce. And let me show you what I mean by that. Okay, so let me write down my zeros first. I've got x equals 0, x equals 10/3, and x equals -5. So I've got 0, -5, 10/3, a little bit more than 3, so like here. Okay, all right, so I notice again, I take a look at my highest power, my degree is 4. Okay, I notice that this term is positive, and the degree is even. So that should mean that it's kind of like a smiley face. It goes up on both sides. Okay, all right, so I'm going to start here. I'm going to go through -5. Now, remember how I said multiplicity 2? This x-intercept has to bounce at x equals 0. So when I come around this way, it's got to bounce off and then come back up this way. Okay, this is our right here in the middle. This is the bounce. And you can kind of think of that as a little mini quadratic. See how it kind of curves down like that? Little mini quadratic, which has the same power as x squared. Mini quadratic. Okay? All right, so this is how we would factor a polynomial and then use factoring to solve for its x-intercepts and maybe sketch the graph. Okay? All right, I'm going to flip to the next page. If I could get my hands on this paper. Okay? All right, we want to do a little bit more factoring in a special way. Okay? So quick review. These are called, this is the difference of perfect squares. And it comes out with this really nice formula. Notice that this is a perfect square, and so is this. Square root of 49, that's 7. Okay, so whenever I see this, it will factor into x plus 7 and x minus 7 every time, which is really nice. It's a nice little pattern. And notice if we multiplied it back out, if we'd used FOIL, we would not get a middle term. It would cancel out. We would get a plus 7x and a minus 7x, and those would cancel each other out. We wouldn't write it down. Now, notice that this says the difference of perfect squares. It does not work if it's addition. This is actually not factorable. So the difference of perfect squares, this special formula for factoring, only works if there's a negative in the middle and both of them are perfect squares. With a plus, it doesn't work because no matter what, in order to get that plus, we would get a middle term even if we tried to factor it. Okay, so this is not factorable. All right, now a new one. Instead of doing perfect squares, we want to do perfect cubes. Okay, so there is a specific formula for this, and I would recommend that you memorize just the placement of each of these things. The core concept is, though, that this is a perfect square and this is a perfect square. So let's take it, the cube root of x cubed, well, that's just x. We'll call that a. Okay, that way we know where to put it in the formula up here that we're using. And the cube root, notice I'm not taking the sign with me, of 8 is actually 2. We'll call that b, so we know where to put it in the formula. Okay, so let me write out this formula for you just one time. All right, so the formula, I like to write it out first. It's an a and then a b, and then an a squared, ab, and then b squared. That's the same. You'll notice that's the same in both if it's a plus in the middle or a minus in the middle. Okay? Now, there's a special acronym we can use to memorize what signs, and we call it SOAP. Okay? The first sign is the same sign. The second one is the opposite sign. And the last one is always positive. So when I'm filling in these signs here, it should be the same sign that I started with. Well, I started with a negative, so this should be the same. Okay? The next one should be opposite. Okay, so that's the opposite of this. That means it's a plus. And the last one is always positive. Okay, so that's a little way to memorize how to put this all together. Now, we said that A was x and B was 2, so let's start putting it together. So I've got x minus 2. Okay, and here's where it's really important to use parentheses, even if it doesn't feel like it's necessary. Put parentheses around A when you're squaring it. You'll see why in the next example, okay? Plus x times 2 plus, and the same for B. Okay, now let's make it look a little bit nicer. So x minus 2. When I square x, I just get x squared plus, let's call this 2x. And then when I square 2, I get 4. Okay, and that's it. This is the factored form of the difference of perfect cubes. Okay, notice that this is actually not factorable. We could not do anything to this anymore. Okay. We actually get one real root if we set this equal to 0, and then using the quadratic formula, this would give us imaginary roots. Okay, so this doesn't factor anymore. All right, let's try one more example. All right, I'll write out my formula. Actually, let's determine what A and B are first. So A is going to be the cube root of 64x cubed. Okay, that's actually 4x. Right? Yes. Okay. Then B will be the cube root of 125, which is 5. Okay, so we've got our two, our A and our B. And then let me write out the formula again. So I've got A, B. A squared, A times B, B squared. Okay, and I use SOAP to fill in the signs. So S stands for same sign. I started with a positive, put the same sign here. O stands for opposite, so I should put the opposite sign, a negative, right there. The last one, AP, stands for always positive. So I always put a positive sign at the back. Okay, let's fill this in. All right, so I've got 4x plus 5. And this is where the parentheses are really necessary. 4x squared minus 4x times 5 plus 5 squared. Okay, that keeps me organized. All right, then I say this is 4x plus 5. And see, if we hadn't written these parentheses, we might be tempted just to square the x. Well, we need to square all of it. So this, in fact, is 16x squared minus 20x plus 25. Okay, good to go? All right, I will leave these for you to try on your own. I'm not going to show the work for these, but I will give you the final answer. Okay, I'll give you that this A is 2x and this B is 3. Okay, I should get 2x plus 3. You see that? Yes. Okay, good. Then 4x squared. Oops, I got my signs wrong. It should be SOAP, same. Then opposite, so minus 6x, always positive, plus 9. Okay, that should be my final answer. For this one, I'm getting A is 10m, and we treat m just like x, just another variable. Okay, and then B, the cube root of 343. Okay, so cube root of 343 is 7. Sorry, I had to go find my calculator there. All right, so that means my formula should be 10m minus 7, 100m squared plus 70m, okay, and plus 49. Okay. Okay, check yourself, and if I made a mistake, let me know. It's possible. Okay, so let's move on to a little review. Okay, factoring is really, really important, but also so is knowing kind of these definitions. All right, how to interpret a graph, how to get some information just from this. All right, so a review is that the degree of a polynomial, okay, this is the highest exponent, okay, it's the number of turning points plus 1. Okay. The degree also tells me the total number of zeros. It could be broken up into real and imaginary. Okay, so let's take a look. Let me label the turning points a little star. Remember, that's where the graph turns around. So there's 1 turning point, 2 turning points, 3 turning points. So I see 3 turning points plus 1, that's 4. So my degree should be 4. That means there are 4 total zeros. How many do we count on this graph? 1, 2, 3, 4. Perfect. So there are actually 4 real zeros. That means that there are 0 imaginary. If all of them are real, then there should be 0 imaginaries. Okay? All right, what about this one? I see 1, 2, 3, 4. Okay, so 4 plus 1, 5, so my degree is 5. That means there should be 5 total zeros. How many real zeros do I count? 1, 2, 3. Only 3 real zeros. Okay, 5 minus 3, that leaves 2 for being imaginary. Okay, all right. Last one, ooh, and this one is a little bit tricky. Notice this right here. This is another one of those, this is a bounce. Remember that counts for 2 zeros. Okay? All right, so first let's do the turning points. This is actually also a turning point, so 1, 2, 3. Okay? 3 plus 1, we're getting a degree of 4. Okay, and then let's label the total number of zeros. This one counts as 1, 2, 3, and 4. So there are, 4 real zeros. Knowing that the degree gives me total zeros, should be 4, that leaves 0 imaginaries. Okay? All right, so summary, degrees is the same as total zeros. There could be real zeros, we can find them on the graph, it's where it hits the x-axis, and imaginary zeros. Imaginary zeros we can't identify on here because they're imaginary. So we rely on the fact that we can see the real ones, and then we take total zeros minus real zeros should give us how many imaginary are left over. Okay, so let's try this in practice. We've got this equation x cubed plus 8. Ooh, this is the sum of a perfect cube. We factor this on the last page. So let me set this up, x cubed plus 8. If we factor using our formula on the last page, we will get that this is x plus 2, x squared minus 2x plus 4. Okay? And we want to set each of these equal to 0. Okay? X plus 2 equals 0, and x squared minus 2x plus 4 equals 0. Well, this one's nice to solve. I'll subtract 2. X equals negative 2. Okay? All right, now before we do this one, okay, I want to think about, first let's fill in some of these blanks. The degrees. Okay, that's the highest exponent. The highest exponent is 3. It's the same as total number of zeros, so there should also be 3 zeros here. Okay, this is 1 real zero. Now let's see if we get any real ones from here. Remember, we're going to use the quadratic formula because this is not factorable. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can sing it to yourself in your head. Okay. Remember that A is 1, B is -2, and C is 4. So when I fill in my formula, -2 plus or minus square root of -2 squared minus 4 times 1 times 4 all over, and this is a mistake I see a little too often, everything needs to be in the fraction, all over 2 times 1. Okay, let's simplify that a little bit. So I'm getting 2 plus or minus the square root of 4 minus 16, oops, all over 2. Uh-oh, take a look at that. 4 minus 16, that's -12. Okay, if we have a negative inside of a square root, that means we're going to get imaginary. These are imaginary solutions. And if we simplify, okay, if I take out that negative as an I, okay, and I split this up, I'm going to get 2i square root of 3 over 2. Simplifying fully, I'll get 1 plus or minus I square root of 3. This is a complex number. We're not capable of graphing this in the real number plane. But notice there are 2 imaginary zeros, 1 plus I square root of 3 and 1 minus I square root of 3. So I get 1 real zero and 2 imaginary zeros. Okay, my real zero is at -2. Okay, this is a positive odd function, so it should start at the bottom, go up to the top. Okay, all right. And we can check that in our graphing calculator. Now, I might not have drawn it to scale. I might have drawn it a little too short, but make sure you check that in your graphing calculator. All right, those are 2 imaginary solutions, 1 real solution. Okay, now let's talk a little bit more about factoring. I've got 2 other methods I want to show you really quick. And this is the last thing we're going to learn in this quarter. Okay, so I have factoring by grouping first, and maybe you've seen this a little bit in Algebra 1. Okay, but notice here, instead of having just 3 terms, I actually have 4 terms now. All right, let's fill out some of this though first. My degrees, well, it's the highest exponent, it's a 3. That means there are 3 total zeros. We'll see if we can determine the real and imaginary without looking at the calculator first. So let me rewrite just to give myself a little space. Okay, the idea behind factoring by grouping is that we're just going to we're going to divide this kind of in half. We're just going to say, like, you know what? Let's do these 2 together and these 2 together. And the great thing is you can choose however you want to group it. Sometimes this won't work. It won't be like right in order. Okay? Choose how you want to group it. So let me just factor these 2, totally ignoring this side really quick. These 2 they don't have any numbers in common, but they do have at least 2 x's in common. So I'm going to write that out to the side, x squared. If I pull out a GCF of x squared from just these 2, I'm going to get an x plus 4. Okay, here's my little line. Okay, and then let's deal with these 2. These 2 do have a number in common. That -3 is what they have in common. So let's pull that out as a GCF. If I pull out the -3, again, I get x plus 4. And that's exactly what you want. Do you see how this factor and this factor are the same? This big parentheses is now the GCF of these 2 terms. So let's pull that out to the front. So I pull out that x plus 4. Okay, if I cover it up on this side, the only thing that's left is x squared. Okay, and if I cover it up on this side, the only thing that's left is -3. And that's it. You have factored by grouping. Okay, let's use our finding the zeros method to determine how many real and imaginary we have. So I set both equal to 0. Okay, this one I get x equals -4. And this one I'm going to get x squared equals 3. X equals square root of 3. But remember, when I take the square root of something, when I start with a squared and I take a square root, I have to write plus or minus because I have two possible answers. So these are all real numbers. Notice this is a positive inside the square roots. That's a real number. So there are actually 1, 2, 3 real zeros. That means there are 0 imaginary zeros. Okay, let's put them on the graph. Let's scoot this over a little bit. I've got -4, which is like way out here, negative square root of 3, and square root of 3. Okay, this is a positive odd function. Okay, positive odd. So that means we need to start at the bottom, end at the top. All right, so if I draw a little sketch, notice that none of them have a multiplicity of 2, so there's no bouncing. They all just go through one time. And there you go. All right, let's try one more together. Okay. First, let me make sure this is equal to 0. It is. Great. Then I'm looking for the degree, highest exponent. That's 3. Okay, that means there are 3 total zeros. Let's work on finding the real and imaginary. So I'm going to rewrite. I've got 2x cubed minus 2x squared plus 3x minus 3 equals 0. Okay, and I will, once again, I'll just cut it right down the middle. Okay. If I just look at these two, I notice that they both have a 2 in common, and they both have at least 2 x's. So I will pull out a 2x squared. Okay. If I pull out a 2x squared from here, I get 1x left over, because I pulled out the 2, and I pulled out 2 of these x's. And then I pulled everything out of here. And it is tempting to say that this is 0. But remember that I have to be able to multiply it back and make it look like this. So really, if I divide 2x squared by 2x squared, I get 1. Okay? All right, let's try the other side. Let me draw a little line. Okay, these two have a 3 in common. No variables though. But if I take out a 3, I get x minus 1. Perfect, we did it right, because I see this and this are the same. So I write that out front. Okay. Cover it up. What's left? That's a 2x squared. Cover it up. What's left? Just 3. Okay, and that's a positive 3. It's not a negative 3. Okay, so we've got our factors. So my zeros come when I set each factor equal to 0. So this one will be x equals 1. That's real. But this one I get x squared equals -3/2. Uh-oh. Well, when I take the square root, I get plus or minus the square root of -3/2. Well, if I have a negative inside a square root, that means it's imaginary. So I have 1 real 0, that's this one, and 2 imaginary zeros. So when I plot this on my graph, okay, I only have x equals 1. That's it. And this is positive and odd. So again, I should start at the bottom, okay, and work my way towards the top. Okay, I'll do a rough sketch. I'm not 1000% sure that this is what this should look like, but maybe something like that. Okay. Remember, you can always check with your calculator. Check with your calculator. Okay. That is by grouping. Kind of divide it in half and look at each piece. You want to factor something out. Pull out a GCF so you get the same thing here as you do over here. Pull out a GCF, same thing here, same thing here. We're dealing with them totally separately. That's why I drew that line. Okay. This says solve by U substitution. Okay, and you might see this in some other textbooks, or maybe if you're working with like a tutor. You can do U substitution. U substitution means assigning a variable to be something in your equation right now. Okay, I want you to try just factoring by the tree. I think it'll work every time. So we'll do that in a second. But first, I look at degree. Highest exponent is 4. So that means there should be 4 total zeros. Okay, so let me set up my little tree here. I've got x to the 4th minus 3x squared minus 4. Okay, it is equal to 0, so I am ready to factor. Remember that we're following film, FLM. So first, last, middle. Okay, 2 factors, it's probably going to be even because it has something times itself. And we're going to end up with an x squared here. So I'm going to put x squared and x squared. You can try multiple things. It's always good to have an eraser. Okay, and then we need -4. All right, well, let me think about this. If I need to get to -3, if I put like a 2 and a -2, those are going to cancel each other out. But if I put a -4 and a 1, those won't cancel each other out. So when I multiply, I'm going to get -4x plus 1x, oops, excuse me, 4x squared. It's 1x squared. Okay? All right, and notice that I made the 4 the -1 because I knew I needed to get to -3. So that worked out. My factors are x squared plus 1 and x squared minus 4. Wait a second though. What is this? This is the difference of perfect squares. This is close, but remember it's addition, so that doesn't count. This one is not factorable because it's the addition of perfect squares. This one is the subtraction or the difference of perfect squares. This is a perfect square of x. This is a perfect square of 2. Okay? So if it's a difference of perfect squares, our special formula says it's x minus 2 and x plus 2. Ta-da! All right. Now this is fully factored. These don't factor anymore. This doesn't factor. We're good to go. So I set each one equal to 0. Here I'm getting x equals 2. Let's put that right there. This is x equals -2. Same place. Okay, but this is x squared equals -1. So when I take the square root, I get plus or minus the square root of -1. And hopefully you remember that the square root of -1, that's I. So I've got one real solution right here, another real solution right here, and 2 imaginary solutions. So I have 2 reals and 2 imaginaries. Remember, I can't put the imaginaries on the graph. Last thing I want to do when I sketch this is note that this is a positive, even function. So it should be going up and up. Okay, so it should look something like, kind of like a quadratic, almost. Okay, something like that. All right, and that is it. That is the last thing we need to know. So what did we do today? We solved polynomials by factoring. Most important thing was setting equal to 0. Set equal to 0 and pull out the GCF first. Okay, we reminded ourselves that when we set our factors equal to 0, we can find the zeros. Okay, we reviewed difference of perfect squares, and we learned how to factor perfect cubes, both the addition and the subtraction. So this is a formula we want to memorize. Okay, a little note to yourself. Also SOAP, that's what this means, the signs. Okay, then we reviewed some vocab. We talked about real and imaginary zeros, and we factored it, and we sketched some graphs. Okay, we also factored by grouping, dividing it. If it has 4 terms, we just divided it in half. We said, hey, let's deal with this one first and this one separately. Okay, again, sketching. And then we didn't do solving by u substitution. Instead, we used our tree, even though it was something that wasn't x squared. Notice that it was an even power, though. If it's not an even power, I would be careful. Okay, this is nice because it's an even power. Found our zeros, or found our factors, excuse me, then found our zeros and sketched. Okay, all right, hopefully this was helpful. Please let me know if you have any questions, and come in, either email or come in to get help.